All right, so we're going to look at electricity today, specifically static electricity. So you have to understand that static electricity starts with friction. Remember, we talked about friction being that force that opposes motion, that prevents motion. So friction is going to end up causing the electrons to be transferred from one object to another. So if you think about it in real life, if you take a balloon and you blow it up and you rub it on your head, that creates friction, right? There's that resistance. So what's happening is the balloon is taking electrons from your hair and they're transferred to the balloon. So you lose electrons in your hair and the balloon then has more electrons. And so it works with any object, many objects. And if you have friction, that resistance, you're going to scrape off, you're going to peel off electrons from one object and then they're transferred to another one. This creates a buildup of electrical charges, and that's what we call static electricity. It works the same way if, especially in the wintertime, this works. But if you have like carpet and you scoot like your bare feet across the carpet and then you go to touch a doorknob, and it can work in a car too if you have cloth seats in a car and you scoot across the car and then you go to touch a piece of metal like the doorknob or door frame on a car or something, right? You're going to feel that little shock, right? That shock is the static electricity you've built up by scooting across the floor. You've transferred electrons from the carpet to yourself, and so now you have extra electrons that you don't need. And so when you go to touch something like metal, your body naturally gets rid of those extra electrons. That buildup of electrons is called static electricity. So now the object has more electrical charges, and electricity is generated when you have that flow of electrons between the different um, objects. Now, conductors will allow the flow of electricity. So when you create a circuit, as you'll do, what happens is if in a circuit, which is just a path that electricity flows through, conductors are things that will allow electricity to flow. So if you have electricity flowing and then you have certain types of materials like copper and other types of metal, they're really good conductors, so the electricity will continue to flow into your circuit. And so copper is a very common conductor. It's a very good conductor. And so what you'll see if you take like wiring, electrical wiring, and you peel the like rubber plastic coating off and you look inside, you're going to see that there's copper wiring inside because copper is a very, very good conductor. And so it will very easily allow electrons to keep flowing through the circuit. So you have this flow of electrons. And of course, like I said, metals are also good conductors. If you think back to when we did the periodic table, metals tend to be good conductors, so most metals will conduct electricity. Right, so that's why you don't want to take like a metal fork, stick into an electrical socket, right? You're going to shock yourself because there's electrical current flowing from the socket to the metal fork to you. So do not stick metal into an electrical socket. You will shock yourself, right, and get electrocuted. Now, insulators do the opposite. Insulators will restrict or block the flow of an electrical current. So if you put some kind of object into an electrical circuit, a pathway where electricity is, and the electricity stops flowing, then that's an insulator. The object would be an insulator. So common insulators are things like rubber, which is why if you take and put rubber into an electrical circuit, then that would restrict or block the flow of electrons because the electrons can't go through the rubber material to end up completing the circuit. Right? And there's all kinds of insulators, and you'll explore and figure out some insulators in just a little bit.